Hello. So, in the discussion of vector, today's topic is unit vector, and as the name suggests, it is a vector which has unit magnitude. Actually, it is associated with the vector. So, if A is the vector, then its unit vector A cap is equal to vector value of A divided by its magnitude. So, but why unit vector is so important? Because if I just cross multiply it, then it reveals its importance. So, we generally how we define vectors. The vector have unit vectors have magnitude as well as direction. So this is magnitude, and this unit vector represents the direction of that vector. So actually unit vector is the mathematical expression of the direction of the vector. So if we talk about coordinates, there are in 3 dimension x-axis, y-axis and z-axis. So these are some specified directions. Otherwise there are geographical direction and there are page wise direction, plane of the paper, left, left, right, up, down, then outward and inward. And if we talk about geographical direction, then up, down, east, west, north, south. But in physics we use the direction associated with coordinate as maximum as possible. So here what we are going to explain is, because these are some fixed direction, x-axis, y-axis and z-axis, so we have associated 3 unit vectors with them. So along x-axis the unit vector is I cap, along y-axis unit vector is j cap, and along z-axis unit vector is k cap. So if there is a force, generally if in this discussion of unit of vectors, I will generally use the example of force or displacement. They are just there because they are easy to imagine. Uh, so that is why. So let us suppose there is a force of 10 Newton along x-axis. So instead of writing entire this, I can write magnitude is 10, unit vector is I cap Newton. Force of 10 Newton along negative x-axis, still no problem, 10 minus I cap Newton or minus 10 I cap Newton. Same for y-axis, same for z-axis. But what if the vector is neither along the direction of x-axis, nor along the y-axis, nor along the z-axis, but if it is somewhere lying in a plane or in 3 dimensions, somewhere there. So in such a case, how are we going to write that vector? If that vector has magnitude 10 and it is little bit along x-axis, little bit along y and little bit along z-axis, it is in between them, it is in the 3 dimensional structure somewhere there, like I have put this styler. It is not lying in this plane but somewhere here. In fact, if it is lying in the plane, it is not either along x-axis or y-axis, it is between them. Then how are we going to put these unit vector with this? So for that there is another discussion, and that is component of a vector along coordinate axis. Okay, so what are components? So actually what we can do, we can split a vector into number of vectors. That is called resolution of a vector. So we can split a vector into number of vector as we require, and those resolved part, if they sum up together and they give the effect of that particular vector again, then those parts are called its components. So it means if there is a vector and I am able to divide it into some number of vectors, then these are add up together to give this vector, then these parts will be called its components. Okay, so component of a vector along coordinate axis. For the sake of simplicity, I am taking only two-dimensional case, and there is a vector. Vector is A. I'm taking its magnitude because I'm doing this mm, I'm doing this resolution, or I'm resolving this vector purely in geometrical manner and trigonometric, of course. So if this is a vector A, and let us suppose take the example of displacement. If a body get displaced along this direction, so if we are interested a motion for a motion along x-axis, then we will say that okay, it has traveled this much distance along x-axis. Actually it has gone somewhere there, but if we are only interested its approach toward x-axis, then only this value is significant for us. Or let us suppose there is a car which is running this way, and we are going to record it, and this is a track over which we have put our camera, and our camera can go this way only. Then while recording this object to reach this point, we have to travel along x-axis or that particular track up to this level only, this distance only. Actually it has traveled this much, but along this axis it has traveled, we have to travel only this much because it has approached x-axis only up to this value, and in the same way it has approached y-axis only up to this value. So we can say that these two vectors together form this single vector, and that is totally true also. This displacement can also be achieved if first we get displaced through this amount of displacement, and then we get displaced through this amount of displacement. Still the result will be the same. So this is what the component mean. So we can say we have resolved this vector into two vectors. Now you might say that okay, it is applicable for displacement, what about force? Yeah, so let us suppose in the game of carom, there is a striker and there is a coin, and we have struck this coin, but we have applied force this way, and this coin has moved this way. Actually, it receives a part of impact of uh, this force. Only this component of force have been applied to this coin. If otherwise this coin was somewhere here, and if it would undergo the full collision, head-on collision, then it might go farther distance than this. Okay. So let us suppose there is a vector A and it is at an angle theta with x-axis. It can be at an angle theta with y-axis also, no problem with that, but I am taking this case only. So A is at an angle theta with x-axis, and the component of this vector A along x-axis is ax, and along y-axis is ay. Then it's obvious, this is ay, so this is also ay. So it's obvious that this A is equal to root of ax square plus ay square, pure geometrically. But what is this ax all about? Now we will take little bit help of trigonometry. So can we find sine theta and cos theta? So sine theta is ay by a. So from here we can say this y component according to this situation will be a sine theta, and here cos theta is ax by a, so this ax is equal to a cos theta. Now if we square and add both of them, we will get a square sine square theta plus a square cos square theta, and on other side we would have ay square plus ax square, or if we take it common, sine square theta plus cos square theta will be 1. So finally we will arrive the same result as given by Pythagoras theorem. What does it mean? It means that this vector A has two components along x-axis and y-axis. It can be resolved into third coordinate also, z coordinate also, and it can be resolved in any direction, in any form. But mostly in mathematical operations, in physics, generally we uh, resolve a vector along a rectangular set of coordinate. It is not bounded to this x and y axis only. It can be like this, that this is a vector A and I have chosen a direction, an axis this way, this is theta, so this is a cos theta, and another axis which is perpendicular to this chosen axis, along this it will be a sine theta. So don't just stick to this relation, but uh, interpret these outcomes to any of the situation. The component with which we have this angle given, that component will be in terms of cos theta, and perpendicular to that the axis along which there is a component ay, that component will be sine theta term. So the component along the axis along which angle is given, that will be cos theta component, and the perpendicular to it, that will be sin theta component. What is the conclusion for that? Okay, but before that, one more thing we can do. We can divide both of them and we can find angle between them in terms of their components. So if we write sin theta by a cos theta, ideally we do it like this. Otherwise we can take it, we can find it in any way, sin theta upon cos theta or cos theta upon sin theta. It's not uh, it doesn't matter. So here it is tan theta is equal to ay by ax. Okay, now what is the bottom line of all of it? Ah, before moving ahead, uh, let me erase this thing, and I'm just imposing a representation to you. As I said, that these resolved parts, and see I am right now writing them as ax vector. Till here I was using their scalar notation. Remember one thing, vector have a liberty, we can write them in vector form as well as in scalar form, whereas scalar can only be written in the form of scalars. So ax ay vector, and they together form this vector a. What is this ax vector? Earlier it was just a component and I haven't mentioned it in a vector form. What makes it vector? So if your answer is ax vector is ax multiplied by I cap, then you are definitely right. In the same way, ay is equal to ay j cap, then this vector a is equal to ax vector plus ay vector, and this is what the resolution of vector all about. Actually, I was uh, I plan to tell you about unit vector, but side by side I have covered this topic also, resolution of a vector, in which we say that if a vector can be split into a number of vector which gives the same effect that of main vector, then we uh, call this process as resolution of vector, and those resolved part are called component of that vector. Right now we have resolved these vector into rectangular component along x-axis and y-axis. So these are its components. So a vector is equal to vector a plus vector ax plus vector ay. And now what? Ay j cap. This is how we are going to represent vectors. So if you look at your books, you can find such kind of expression many times when where a vector is given in terms of I cap plus j cap plus k cap form. So this is its vector value. So what is its magnitude value? Now see, we have already obtained this. So here it is, ax square plus ay square. And now we know that component ax is along x-axis, so its unit vector is I cap. Component ay is along y-axis, so its unit vector is j cap. But what is the direction of vector a? Then in order to find the direction of vector A, we will find unit vector associated with vector A. We will mark it as A cap. As per definition, it is vector A by its magnitude, and hence it is Ax I cap plus Ay j cap divided by root of Ax square plus Ay square. End of the discussion. And if, see, I can derive it for 3 dimension also, but why don't I use the symmetry, because in physics there is a symmetry. So for 3D, vector A is equal to Ax I cap plus Ay j cap plus Az k cap, and its magnitude will be, okay, in some video I will derive this separately because it is too time consuming, yet not that difficult. So its unit vector will be Ax I cap plus Ay j cap plus Az k cap divided by root of Ax square plus Ay square plus Az square. So let me give you an example for this. There can be several type of question, but uh, two types are mainly asked in the exams. So first is find unit vector parallel to a vector v equal to 2I cap minus 3j cap. And other question is, if 0.5 I cap plus b j cap minus 0.3 k cap then is a unit vector, then find b. Okay, starting with this unit vector parallel to vector this, we can find its unit vector. How can we find a unit vector parallel to this? So remember, as I told you, unit vector tells the direction. So if we find the unit vector associated with this vector, then the parallel vector will also have same unit vector. I'm not saying same vector, but same unit vector. So simply we can find v cap, which is v vector divided by its magnitude. V vector is 2I cap minus 3j cap divided by, see, it will be 2 square plus minus 3 square. So if in future, if irrespective of their negative sign, if I directly write this, don't think that I have done some mistake, because ultimately it will turn out to be positive, because this entire 3, actually it is 2I cap plus minus 3j cap. So when we do the square of this component minus 3, that will be ultimately positive. So there is no need to put negative sign, you can directly put positive while calculating magnitude. So it is 2I cap minus 3j cap divided by, it is root of 13, and we can say that unit vector parallel to this vector will also be the same for parallel vector. Okay, now what about this? So we know it is unit vector. It means if it is a unit vector, then root of 0.5 square plus b square plus, see, as I told you, that is negative, but what is the use? Ultimately it will be squared, and finally it will come out to be positive. So I have ignored that negative sign, and it is equal to 1. If we square it, uh, root will be removed. Still it is 0.5 square plus b square plus root 3 square is equal to 1, and then it is 0.25 plus b square plus 0.09, okay, equal to 9. So it will be 0.34, it will go that side, equal to 1 minus 0.3434. Yes, of course, 34. Okay, so it will be 0.566. So b is equal to plus minus root of 0.66. This is how, this is not only the case, the things will be worst when we go on, but somewhat the basic structure of entire processing will be the same. So now just focus on this. Actually we have covered two topics in one, not only the unit vector but also how to resolve vector along and perpendicular to a vector. So in next video we will cover such type of problems.